Hello everyone, welcome to Physics Facilitator. So in today's session we are going to continue to learn the chapter which we have started in our previous session, that is laws of motion. In our previous class we have learned Newton's first law of motion, right? So in today's class we are going to learn Newton's second law of motion. Okay, so Newton's second law of motion is nothing but it tells us or it explains us what happens to a object which is at rest when a non-zero force acts on it. Okay, or simply you can say force required for the motion or movement of an object depends on the mass and velocity of the object, or you can simply give a statement as the rate of change of momentum of an object is proportional to the net force applied on it in the direction of net force. What is momentum here? Momentum is nothing but it is defined as the product of mass and velocity. Okay, so this is what I have said in the second statement, right? So momentum is nothing but it is the product of mass into velocity. Okay, and momentum is denoted with letter P, mass is denoted with letter M, and velocity is denoted with letter V. So P equal to mv, and the SI units of momentum is kg meter per seconds or Newton seconds. Okay, so for example, if you have a ball and you have kept that ball on the ground. Now, ball is at rest or in motion, it is definitely in a rest position, right? And if you give a push to that ball or you kick that ball, then only the ball has moved. So the ball is changing its position from rest position to motion, right? So whenever you are applying certain force on the ball, then only it is accelerating and attaining the motion. So a non-zero net force acting on the body disturbs the state of equilibrium of that particular object or a body, right? So to understand how the acceleration of the object or the body depends on the applied force, we are learning momentum. So for example, if you are targeting a wall and firing with a gun, so the bullet coming out of the gun makes a huge damage to the wall. How this is happening? It is in a small size, but it is damaging more wall. The velocity with which the bullet has been fired is very high. This is the reason the bullet is damaging the wall more. And for example, if you have a heavy truck and a bicycle, if you hit the wall with same speed, then which one damages the wall more? Do the bicycle damage the wall more or truck damages the wall? Definitely the truck will damage the wall more. Why? The mass and velocity of the truck will be high compared to bicycle. So definitely due to high mass and velocity, the truck will damage the wall more. What is happening here? Momentum is more. So by this we can say that momentum depends on two factors, that is mass and velocity. In case 1 which I have said that firing a bullet, in that case velocity was more, so there was also momentum more. In second case also mass was more, so momentum was high. So as all objects have mass, if an object is in motion then it acquires momentum, and momentum is a vector quantity. Vector quantity ante enti? Which have both direction and magnitude. So momentum has both direction and magnitude. Why? Because velocity is also a vector quantity, right? By this we can say that the direction of momentum is the direction of velocity, right? Next, larger the net force, greater the acceleration. So what we are doing here, we have taken a block of ice. Okay, after taking this ice, we have to apply some force to push the block of ice. Okay, after pushing it, it will move to a certain length and it will stop, right? So after it stops, again take that ice and again apply some force which is greater than the first force. Okay, that is, now we have to increase the net force and we have to push the block. Now what happens? It will move to further distance than the ఫస్ట్ కేస్, రైట్? ఫస్ట్ కేస్ లో ఫోర్స్ ని తక్కువ అప్లై చేశాం కాబట్టి కొంచెం డిస్టెన్స్ మూవ్ అవుతుంది. సెకండ్ కేస్ లో ఫోర్స్ ఎక్కువ అప్లై చేశాం కాబట్టి ఇంకొంచెం ఎక్కువ మూవ్ అవుతుంది ఫస్ట్ దానికన్నా. ఓకే, వెన్ ది ఆబ్జెక్ట్ హ్యావ్ కాన్స్టెంట్ మాస్, when we are changing the force according to the force it gets accelerated. So that is what we are saying in this. Larger the net force, greater the acceleration. Okay, next, larger the mass, smaller the acceleration. So what we are doing, we have taken two ice blocks which have different masses. One has less mass, one has more mass. Okay, and what we are doing here, we are applying same amount of force onto two blocks of ice. So what is happening here? The ice block which have less mass will speeds up fast compared to the ice block which has more mass. It does not speed up that fast compared to the block which has less mass. Okay, so from these examples we can say that F net is proportional to change in momentum by time. So F net is proportional to, change in momentum is denoted with delta P, right, by time, delta T. Okay, so F net is proportional to delta P by delta T. Okay, so to remove this proportionality sign, we have to replace the proportionality symbol with K. So F net equal to K into delta P by delta T. Okay. So the unit of force is so chosen that the value of K becomes 1. So K equal to 1. What will happen here? F net equal to delta P by delta T. Right. So what is delta P? We all know that P equal to mv. P is momentum, right? Momentum is product of mass and velocity. So P equal to mv and delta P equal to delta mv and delta P equal to m delta v. When we are assuming the mass of body is constant, okay, then we will write m delta v. Okay, now let us substitute this in this equation. Okay, what you will get? F net equal to m delta v by delta t. So what is delta v by delta t? It is acceleration, right? Delta v by delta t equal to uniform acceleration. So we have to replace this delta v by delta t with a. So what you will get? F net equal to ma. So by this equation we can say that the net force produces acceleration in a body or object in the direction of the force. Okay. And the SI units of force are kg meter per second square. So this unit is named as Newton N. So 1 N equal to 1 kg meter per second square. Okay. So the force units are simply Newton. So here F net equal to delta P by delta T is a universal formula. Okay. It can be applied for any system, whereas this F net equal to MA, this can be applied for situations where we have constant mass. That is the system in which we have constant mass. Okay. So what second law is saying is the rate of change of momentum of an object is proportional to the net force applied on the object. So this is what we have concluded here. So that's all for today's session. In next session, we are going to learn Newton's third law of motion. Okay. So please like, share and subscribe to my channel and please support my channel. So if you have any doubts or queries about these topics, please do comment me in the comment box. Okay. Let us meet in another amazing session.